Good morning. I am Joe Kovacic, and I work in the DISA Emerging Technology Directorate. We would like to welcome you to today's technical exchange meeting. Immersive Fusion will present its Tier 1 support enablement, streamlined root cause analysis, and software application performance management capability in today's session. I need to go over some administrative items before we get started. First, please mute your DoD 365 joint Microsoft Teams sessions. Second, this session is being recorded to allow future scrutiny presented capability by members of DISA and the DoD community. Third, this is a public forum, so no proprietary or sensitive information should be shared in this session. Fourth, we encourage questions during the session, so please use the raise hand function in the Teams menu to alert the presenters when you have a question. You can also enter your questions in the chat area anytime during the presentation. Questions will be addressed in the order they are received. I must provide the following disclaimer. This technical exchange meeting does not infer any intention by DISA or the Department of Defense to enter into an acquisition, contract, purchase, or endorsement of the presented capability. This session is purely for informational purposes only. We do not control how session participants will proceed with the conveyed content. Access to the technical exchange video, slide deck, and other artifacts will be made available through the public TEM website. A link to the session slide deck will be posted in the chat area shortly. And with that said, let us commence with the presentation. So over to Immersive Fusion.
Hello, everybody. Can you see me, hear me clearly?
Yes, we do.
Wonderful.
Thank you. Thank you, Mr. Kovacic, for inviting us here, and also thanks for everybody for joining the session. What I'm going to talk about today is Tier 1 support enablement, as mentioned. And one of the, for those of you, most of you are probably aware, Tier 1 support is generally the first line of defense for basic issues and things that happen with various organizations where they need to support their software. And a lot of times those individuals have breadth of information. They have general knowledge over basic functionalities of software. But when it comes to depth, they might not have the required training. And so at that point, we end up in a situation where we need to expedite or escalate an issue to appropriate resources. And our tooling, in order to be able to do that, makes a key difference around that. I'm going to share a link inside of the chat. I will not be using it just yet, but I'd like to have part of this conversation be somewhat interactive. So at some point I might say, please click the link and click some buttons, but for now, just have it at the ready. The presentation that I'm going to go over as soon as I get the clicker to click is provided by Immersive Fusion. The presenters and the people listed on this slide are advisors and champions of the organization. They're not employed by Immersive Fusion, and we volunteer our time to provide guidance as to the direction of the product by bringing our prior experience to the organization. I myself, my name is Dobry Kolev. I'm a senior principal software engineer, and by trade I deal with distributed computing, high performance volume data processing, and other large scalable software. And as such, I have had a lot of experience with not being able to know what an application is doing, and if it's broken, the types of hassles and headaches that are encountered along the way. We also have John Kunz, who is basically our champion around Zero Trust. He also brings a lot of expertise from prior experiences. Tim was not able to join us today, but he is assisting in the business development side and how we do our outreach. And then Carl is a champion from a customer perspective that is joining us here in case there's customer or usage-centric questions that the audience may have. And so I have you for 60 minutes, and I hope that we have a very engaging and fun conversation. I will leave time at the end to have Q&A, but the general flow would be that I'll share some context scenarios of, just to set the stage and discuss some brief background around application complexity and then issues that software that's running encounters. And then we'll talk a little bit about observability and what it is, and then the gaps in observability that are currently prevalent in industry. Then we'll talk about some innovation and how Immersive Fusion sees the problem and its solution in the long run. And then we'll go into a demonstration. Depending on how well we do on time, I have a bonus demonstration as well, which I think will be also fun for the audience to see. And then we'll just do some recap, some call to actions, and then open it up for question and answers. Before I begin, anything anybody wants to bring up, or should we just dive into it? All right. So I'm going to start out with some critical and stressful takes from the day of tier one support engineer. Something is wrong with a particular system, and we don't know what it is, but it's obviously something's not working. Or an engineer needs to determine if the issue is transient or it's a bug, meaning did the internet just go out or is the software faulty? Another part is, a server's down, or is it the backend having issues, or is it anything in the data center? Is it from the user's computer to wherever it needs to happen? A lot of times we have situations where a non-database administrator, typically a tier one that's not versed in whatever that database is, has to figure out if it is a database problem or, again, a transient or some other issue. Also, hiring a tier one support representative is stressful in and of itself. And so, being thrown in the deep end is usually a difficult thing to swallow on your first day or a few weeks of employment. And so the end goal is that we need to get the problem fixed. We need to figure out what it is. We need to get the right people involved and get it resolved right away. And some of the things that go against us in such endeavors are just the organic growth of software. In other words, we have software complexity that just happens to be more complex as time goes by. Server applications used to run on single computers, and you could easily just walk over to that computer, open it up, look at the event viewer, and find out what potentially could be the issue. But as time goes by, applications become more and more distributed. Microservice applications will inevitably make this troubleshooting experience somewhat difficult because they are on different pieces of hardware or virtual machinery. And then not for nothing or not for last, the lines of code and application will just grow to are significantly contributing to that aspect as well. Whether it's just natural feature progression or just legacy code that hasn't been removed. Conversely, when an application is running, there are things that happen to it. And some bugs or some issues are easily reproducible. They are, it always happens the same way. I go click this button and it always just does this. And I can send the screenshot to whoever needs to figure it out, and then they can go on. But other bugs that are transient or other issues that are transient, they end up having a little bit of a more challenging experience because they may go away, they may come back, and generally you need to have a really good supportability story or the tooling to be able to just really dive into it, know exactly what's going on. And from the perspective of a tier one support representative, that could be challenging if you don't have the right tool at hand. Observability or the observability tools that are available in industry are basically software that allows us to see what's happening under the hood. It helps us get the visibility that we need from how the software works, how it's performing, what its errors are, and effectively, is it healthy? or does it require additional tuning, resourcing, or other type of maintenance? What we have found is that organizations don't have a full observability. A lot of times, observability or the tooling around it is an afterthought. In other words, we will release some piece of software somewhere in the wild, it will stop working, and then we don't know what to do. So now it's a fire to figure out, well, excuse me, how do we get this information that we need in order to solve this? Um, and then also, 48% of organizations um, just report that they have no knowledge of the tooling. Even if there's tooling existing in the organization, they don't know how to use it. And whether it's prevalence around the training, or the tool is hard to use, or the tool is only provisioned for a certain set of individuals, the point is that we just have an accessibility, we have a barrier to entry that we need to break down. The challenges, as I pointed out, is that we know, and we've heard from customers far and wide, that the way that applications are being troubleshot right now is that that process is burdensome, complex, and requires a lot of effort in terms of either getting it going or using it or figuring it out. And on top of that, it can cost a lot of money. And so the breakdown around about how organizations look at are currently the state of the art was broken down by a study that was done where 11% of the organizations don't even think about it. It's just they either focus on features or aren't aware that that sort of capability is a mandate. There's really no question around it. You have to know when something is not working. Otherwise, you end up having issues with downtime, unavailable systems that could be critical to life safety, to any type of functionality that is paramount or really necessary. The the place that we're in today is a pivotal point in time. And we have either zero visibility or zero dimensions, no monitoring of any kind. And we're just kind of with our hands tied. Or we can progress and we can look at the logs of an application. There's plenty of tools out there that will collect logs from various systems and make them available. The problem is it's just a plethora of information that is not exactly useful, especially as your systems become larger and larger or become more distributed, or if you need to know what other variables are involved into this. Like in some situations when several servers are having a problem, it might not even be an issue with the software. It could just be a transient or one of the dependencies that that is in place that's having the problem. We can then move forward into having dashboards, and also there's a lot of tools around that, and those dashboards show error rates and show basically what it is from a certain formula perspective. P99s, that's kind of a term that's used for slow results, really slow response times. But those are not immediately intuitive, and if you know what that is, great. But most people don't. The direction then becomes, well, how do we take that? And the reason why the red arrow is a little bit to the left is partially because of the previous slide, which said that a lot of organizations are not using this information. They are not aware that this information is available. As we progress to the right, the problem becomes evident that even if you have all the information at hand, all of the dashboards, if you do not take time as an aspect, or the dimension of time as an aspect to what you're doing, then if essentially you don't really have any bearing on when it happened and when the issue actually occurred. Yes, certainly you could use filtration and you could say, well, show me the stuff that happened at 9 a.m., but that's clunky at best. And so effectively, where we need to be is a way that we could leverage the two-dimensional aspects, which is the data itself, the logs and what the application is doing, or otherwise known as traces, as well as the dashboards that are very critical as well. They really have their own place when you know what you're looking for, but then also combine that in a way that we could leverage the dimensionality of the data so that we can kind of positionally know, okay, this server is talking to that server, that application is having this issue, and or this server is completely isolated, there's nothing talking to it. And then on top of that, also add the element of time. And so either we embrace the fact that real time is a critical aspect, or we will not be able to really truly know exactly what's happening at any point in time in an application. And then how we decide to take that functionality is really up to us. There could be simplified versions that the tier one support personnel is comfortable with that has to do just with the two-dimensional aspect of the logs and the traces that are produced by the application. Or it could be a compromise where the tooling evolves itself to a particular uh, point in the future that effectively makes it so easy that it is as though you are in a real world looking out in the sky and seeing the things that are in your application and knowing what to do just by being there, not necessarily having to go through training or anything like that. And that is the balance that we in Immersive Fusion are trying to strike by making technology that is currently ubiquitous and picking up more steam with virtual reality, and make that palatable so that has a purpose outside of just entertainment. Immersive Fusion has several approaches and methodology aspects that are key to the premise of the company. Um, the concept of enter the application is important because in isolation, everything is fairly simple until you start putting them together. And then when it's all together, you can now extrapolate from the relationships and interactions of these pieces of what was happening. Um, the ability to have an alternate approach to what currently equates to log diving or log surfing or wading through logs in a more practical approach. A tier one support engineer will not go through all the logs and be able to connect the dots if all they had was logs at their disposal. While providing high level and detailed views of the application, we should also be able to provide granular operation. In other words, I know that generally this part of the system is having an issue. How do I dive into that piece so that I can understand the intricacies of what particular type of small Heisenbug or other bug that I have in the code are and are taking place? When we're also talking about having the right tooling, we can't ignore the fact that this has to be quick, it has to be painless, it has to be easy for an application of any kind to onboard itself. A lot of the feedback that we've heard and I've personally run into in the past is that onboarding in observability tools is time consuming. It is painful and requires a lot of effort for organizations. And if it doesn't, it's not very customizable, which kind of defeats the purpose of having an observability tool that's supposed to be your lens into what's happening, except it's not really functioning. Um, and last but not least, require little to no training. If you can just use a tool that is just second nature, then you've won. Because at that point, the person that got hired as a tier one support representative can simply just open the application and open a browser or put a VR headset, and then they're off to the races. So empowering tier one support personnel is just a no-brainer. It's just yet another example of how immersive technologies or better tooling can save time and save resources to every organization. If a tier one support engineer is capable to do the basics or even go far into some of the complexities, then they can be self-sustained, they can be aware and well equipped to either solve the problem themselves or involve the right resource that is supposed to take care of it in a timely fashion versus having to wait and then waste precious time. And so even though applications, bugs with applications issues are critical and they're stressful, the process to resolve them does not have to be. Immersive APM is an attempt at this resolution. And it is a product of immersive fusion that is effectively um, aiming to solve those problems. Be able to be the easy tool that requires little training that works with the natural thought process of an individual to help them not really be forced into a solution that they have to learn, but they can pick and choose what applies to them. And therefore, there is a web browser version of that, as well as a virtual reality and a 3D version that is more immersive. And basically, the end goal is I need to figure out what's wrong. That's it. There's, to put it quite simply, I know that there's a problem. I need to figure out how to fix it, and I need to do it quickly. The the first flavor of the APM web is what you would normally be accustomed to if you were a customer. If you were using any observability tools today, you would kind of be used to the grids of data, things that you have to filter through, things you have to use facets and sort and kind of wade through. It's not exactly ideal, but it is the status quo today. It is also more amenable for mobile applications or things on the go, because a lot of times a 3D virtual reality solution requires kind of more of an elaborate setup, such as having a headset or somewhat of a powerful machine, or even a client or software application needs to be installed on the person's computer. If you already have all of that, and you are able to just pop the headset on and you're off to the races, excuse me, you have made significant progress and broken down a lot of barriers. The Immersive APM 3D VR client allows the users to enter the world of the application through either using conventional three-dimensional representations of an application by using keyboard and mouse. And that's kind of reminiscent of various types of games that are out there, but the mechanic is intentionally reused so that it's not something that people have to learn. The VR aspect of that is able to be accomplished by simply switching the behavior of the client when the person puts their headset on. And if we have time, I'd love to show you what that looks like. When the headset is on, the behavior changes. You no longer have the two-dimensional kind of flat feel to a three-dimensional application. You can actually be fully immersed into what's going on. So at that point, the analogy or the metaphor of I'm going to look up in the sky or I'm going to look far in the distance and see if anything's on fire suddenly becomes real. And at this point, I'll take a quick break. If there's any questions, if you want to ask them now, otherwise I will switch gears to do a live demo.
Hi, this is Joe Kovacic from DISA. I got two questions for you. First question is I just curious, like how deeply can this capability look into and find problems within an information system? For example, just say you have an NT architecture, you have application server, database server, and you have an application that interacts with one or more databases in the database server, and suppose like a database administrator goes in there and foolishly drops like a view from one of the databases that an application is dependent on, and now the application on the front end is broken. Like how far deep would your capability be able to discover where that problem originates from? Is it at the application level? Could actually find out that yes, a view was dropped at the back end, and that's the problem that needs to be resolved. Does that make sense?
Yes, absolutely. It's an excellent question. And the answer is deeper than your example. The granularity and the fidelity could be even higher than what you just described. But what you described is a quintessential example of the use of the software and the tool. And it incidentally happens to match exactly the demo material that I was going to show. So for the audience, we didn't rehearse this, but it is a very serendipitous.
Yeah,
Um,
and can I just have one more follow-up question? Uh, this is a problem I encountered when I was doing software development work for the Army. We created a GIS application for the Army, and when we deployed it to a production environment, it broke. It didn't work, and we were losing our minds trying to figure out what was going on. We went over the code, we went over everything, and sure enough, after a lot of torturous iteration through everything, we found out that the required libraries or dependent libraries that were installed, they were like Oracle libraries. They got corrupted. They just, when they put them on the production server, something went wrong during the data upload, and they were corrupted, and that was why the GIS system wouldn't work. Would this again capability be able to discover something to that effect?
yes, sir.
Okay. All
Yes,
right.
absolutely.
All right. Thank you.
Those are excellent questions. Thank you. That's a really great segue into the demo. I'm going to stop sharing my current screen and I'll share a different screen because I have to show two different browser windows. And so the link that I shared in the chat is to this application. Um, and I'll just give you a little bit of background about it. So this is an open source project by Immersive Fusion that centers around this ability of Immersive Fusion to use open standards. And so this open source example is around open telemetry. And open telemetry has been picking up speed over the last couple of years, and now it's very pervasive to the note that to the tune that vendors will have open telemetry instrumentation or the ability to have those granularity hooks into their software as they ship it, and you just have to enable it. There's plenty of examples of this. You can see this browser screen, right? The one that says Chaos Simulator on it. Or am I? Can I get a thumbs up?
Yes, we see it.
Okay. Um, and so there's plenty of examples of open telemetry. And so this one you will see under the Immersive Fusion GitHub account. Um, but there's a clear disclaimer what it's not. And so a lot of times when there's samples and there's example applications that vendors provide, you have to do work. Like you as the user have to go install them or test them out or have an environment to test them. So OpenTelemetry in and of itself has a plethora of tools like that, examples like that, sample applications where you have to go do work. And what Immersive Fusion did is we said, well, we don't really want to make the user do any of that. We just want to let them play with the tool. And so then the idea, and I think John's on the call, it was his idea, that we just give an application that is already deployed so that the customer doesn't have to do anything. And they can just go press some buttons. And so those buttons are these. And we can inject failure or we can eject failure by simply saying, press this button. And so if it was all normal and happy, I can just run a SQL command, and I can have it come back, and it will tell me what it did. Like there's no errors on this. Or I could use another resource like a Redis server, which is kind of like a transient data storage. I can do the same thing. And so at this point, I can go, cool, that's useful, but what's this? And this is generally something that you don't see in observability tools, and you would definitely not see it in a production application. In other words, if I go to um, any website, it's not going to tell me, by the way, this thing failed, and so you should go talk to the maintainers of the software. The reason why it's here is because it's just a shortcut. It's just because of the sample application. It's telling us what it's doing under the hood but it's also sending that off to the observability tool of Immersive APM. If I were to open the view of this demo, and I'm going to put it on a different screen so you can kind of see what that looks like. And so I will go and select the demo grid, which is what this is attached to. And I apologize if it's kind of squished, but it should be fine. And so this is the web client demonstration. And so what we're seeing is that I click the button on the left-hand side, and I can see that behavior in the APM immediately, or close to immediately, about half a second or maybe a second later, which is where the real-time aspect is critical. And then I can keep doing that, and I can see all of my processed things on the right. Now, if I drilled into any one of these, what I'm presented with is a simplified flame graph. In other words, it's for when you're talking about applications, the types of things that occurred when you put the button all the way to the end and back. They're represented as call stacks, and the way that you would usually see them is through flame graphs or through trace viewers that have time dimensions as well, how long something took. And so in this case, I can look at this because I ran a SQL query, and I can see this is the query that was run, and a few other pieces of information around this. And so effectively, this whole button click is this application or this view. If there's any logs attached to this, I don't have to go to a different system to see them. I can just switch to logs and see, oh, it said this, it did that. So the tool combines both I performed this operation and here's the details of this operation, plus I also generated some log data, and it's all in one place. So if I click to that, I know that this button, all it did was, I now know every single thing that happened under the hood in that system. If there are any errors that would show up in here, and let's introduce it. Again, going back to this demo, I just loaded a browser screen that generated a sandbox, and you can see the sandbox GUID on top. I have my own personal space. I did not have to go install software, download anything, or whatever. I just started clicking buttons. Now let's introduce some chaos in here, and I'm going to break the SQL server. I'm also going to break the Redis connection. And when I click this button and I look at my cheat sheet underneath, you'll see that failure. Something happened. Now again, I will not see this under the production system, but I'm going to switch to my view, and I'm just going to refresh this screen. And now I'm going to see that I ran a SQL query that failed. Now, it looks very similar to before, and I can still see things that it tried to do, but I don't see a query. Why? The query that I tried to run, it doesn't seem to, it's not here, and I wonder why. So then I go, fine, you didn't get to running a query, maybe? I don't know. So I look at the logs, and I see that there's some sort of an unhandled exception that occurred, even probably prior to when the database was asked to do anything or to return a result. So then I go into the actual errors, and I see a stack trace. And that stack trace is the places in code that was touched within that operation and what the error was. So now I see that the user can't log in. And if a user can't log in, it can't run queries, which is why I can't run which is why I don't see the error here. And so in essence, you don't really need any training for that. You can just kind of extrapolate what's happening. And by just clicking around, you can just go, okay, fine. I'm just going to copy this to my clipboard and send it to such and such, unless I can fix it myself. And that's power. That we just did this in 5 minutes, and none of you guys and gals had to install anything, but you saw it in action. And I could do the same thing with Redis as well, but in this juncture, that's kind of the flow of this demo. I'm going to go into the other view of how do I start from the log perspective. Like, I don't know what the application does, but I'm just curious to see if there are any logs that are errors and how do I work my way back. And then I can go into some charts, but I'm going to take a pause and see if there's any questions or feedback so far.
Hi, this is Joe Kovacic from DISA again. Just a quick question. When you talk about the logging levels, is the level of detail in the logs, is that something that's configured on your platform, or does it have to actually be instantiated within the target application or database that's being analyzed? Over.
I love those questions. That is awesome stuff. Let me show you. Back to the GitHub. Nope. Sorry, wrong. So this is a sample. So the KS simulator is written in .NET, is a C# .NET application, but the concept is the same. So if I go to source and I look at the program file of this API, the program file describes where it will send the data. And I guess in this case, they didn't configure it. But effectively, the answer to your question, Joe, is whatever the application wants to log, that's what goes out. So the granularity of whatever you're interested in, you could be verbose, or you could just be errors only. It doesn't matter. It's emitted by the application when it runs, and you could change that by changing the application itself. The observability aspect of it is just a totally symbiotic component and complement to the application. There's nothing that you need to do from on the Immersive Fusion side.
Okay, hang on a second. We got an open mic. Hang on. Let me mute that person. Okay. Just another quick follow-up question. Are there restrictions on this platform regards to like operating systems, programming languages, anything like that?
No, sir, there are not. And so this goes back into our discussion that we had before, which was we have open standards. Open telemetry is an open standard where effectively there's a lot of commodity functionality already available out in the field that is maintained through open source contributors. So it's not Immersive Fusion code, it's not Immersive APM, it is packages for any language that is supported. And if we take a look at this list, they're adding languages as we speak. And then when we instrument, the beauty of it, and I have a slide for that, it's not part of the main deck. I can go into it later on. But effectively, what happens is the application will combine these various commodity libraries, and it will say, I want to send this data, the logs and the traces and the metrics, to some destination somewhere. And Immersive APM just is one of those destinations. So effectively, in some cases, we have seen people that have I'm going to send it over here to this open telemetry vendor, and I'm also going to send it over here to Immersive Fusion. And so it's very flexible that way, and it's very, very vendor agnostic, which makes it really easy to make the claim of replacement or trying out new things. And so I'll just go into this example. It's very similar to what you would see in the sandbox, but effectively it's just following a few simple steps that I'm not going to belabor, but effectively, there's examples for most of the mainstream languages. And with that, I'm going to transition to something related, but does that answer your question?
Yes, thank you.
Awesome. So I have here my own account that I used to play with, And in there, I have various grids. And the way that Immersive Fusion refers to these or thinks of those is they are all of the aspects of the application. They're all the APIs, all the database servers, all of the workers, anything that's related in some logical way within a deployment. So if you think my bananas production deployment that has all the bells and whistles and soup to nuts stuff, everything goes into one bucket, and so that's a grid. And in order for me to leverage or be able to send information to that grid, all I need is basically an API key. So I can create any grid that I want just to mess around with or whatever, or I can use one of my existing ones. And so then once it's ready, then I can go to the instrumentation tab that basically gives me the information that I need to tell the commodity OpenTelemetry packages, go send this stuff to Immersive Fusion. And then because I'm using an API key, um, then I'm associating this information to this particular grid. So any of the APIs, workers, front ends, all of them will just dump that data in, and then it'll be together. And then if I don't have one, like I just made this TEM one, if I click instrument, it'll say you don't have an API key. Click to generate, and I click a button. It gives me an API key. I can copy and paste that stuff. And then in the example for the chaos simulator, I'll show you what that code looks like, just so that you can kind of appreciate the level of agnosticity that is provided by the fact that we are following, or Immersive Fusion is following the open standards. So if I go back to the code and I go look at API and go look at Sandbox, the organization here obviously could be whatever custom code organization that the person writing the code can have. But at the end of the day, there is this piece, and I'm not going to explain all of it, but all of this comes from the commodity libraries. This is just the open source aspect of OpenTelemetry. And then at the end of the day, the only other things are these two, the endpoint and the API key. And that you get from here. So even if you took the sample today, the chaos simulator, and you want to run it locally, you would just have to make a grid and copy these two values, and then you could run it easily. And then if you really did want to do that, there's instructions in the README on how to run it. But really, really straightforward stuff. Like we've tried to make the barrier to entry very low. And then once you're in there, then you can start adding more data and just learn from the system, grow the system. And there's a lot of opportunity. So we have 15 minutes. I'm going to take another pause, and I want to kind of go through what I showed, and open it up for quick questions. And then also, because we have a little bit of extra time, I want to go into the bonus demo. I think that'll be fun for people to see. So any questions before I do the summary and then go into the other live demo?
There is a question in the chat. I could just read
Oh,
it
I
off
see.
to you. Are there Army entities that you are working with? Over.
We are currently not working with any military entities. We're strictly, we don't have any, Immersive Fusion doesn't have any limitation on doing that. It's just that there hasn't been an opportunity to make that relationship. And whether or not we host that in government cloud or any other highly privileged cloud, that's already part of the design. So as soon as there's a relationship for this or that makes sense, we can easily turn that around and provision where necessary. Okay.
There are no other questions in chat.
Thank you. So what we showed today is the hard day of a tier 1 support representative. And we found what's wrong with the system. We discovered If an issue is transient or it's a bug, we recognized that the server was not down, but it was having chaos issues. And we verified that it was a problem, it was a database problem, and we showed how we can empower a new hire on their first day of job. We also didn't really spend any more than 10 minutes to show how that was done. So, in a nutshell, we've succeeded on the premise of this conversation, of this talk, which is rapid root cause analysis, the approach that immersive fusion takes to that problem, and how it can really make a difference for an organization. A little bit about immersive fusion. So immersive fusion is an observability innovator. I already mentioned the champions on this slide or this deck are not employed by immersive fusion. We volunteer our time to kind of steer the organization in a proper direction by providing our experience from industry and various obstacles that we've personally run into. But immersive fusion is a young organization, and we are absolutely looking for support in innovating, as well as growing the organization. So your support is absolutely critical. And if there's any opportunity for champions such as ourselves, any partners, any early adopters, any Army entities, we would be ecstatic to have conversations. One more thing before I go into the supplemental demo. There's certain things that immersive fusion does sometimes that are not part of the mainstream aspect. And so, in other words, there's things that we could leverage the immersive fusion platform for, but are more features, not really something that you would do the day-to-day, especially with tier one RCA approach. And so one of those things is the virtual collaboration aspect. And so, in other words, we have a fundraiser that we're running, or the company's running at the moment, where effectively we're trying to leverage the VR aspects of the application so that multiple people that work remotely, much as like this fine group here, but be able to collaborate by, being able to, at the very least, showcase or do whiteboarding together. In other words, we can't be together in real life, but nothing's stopping us from having headsets and collaborate on a whiteboard together by just being in the same virtual space. And so this fundraiser is currently ongoing. And at some point we might make that into the roadmap, but at this juncture, it's a purely feature experiment type of thing. So shameless plug on that one. So the next slide is Q&A, but I'm going to go into the other live demo, which I think the audience will enjoy. So I'm going to stop sharing this, and I will share a different screen. Okay, and please go ahead and tell me if you see a blue sky.
Yeah, it's there.
Okay, so this is a experimental build. So usually software has like pre-releases and they have the release cycles, and this is the concept build, meaning the team at Immersive Fusion uses it to try out new UIs, new flows, new experiences before they make it into the mainstream 3D and VR software. And so it really is trying to embrace the enter the world of your application concept. And so effectively, you will see a lot of mechanics from other software that's not necessarily enterprise, but it is intentional such that we can reduce the barrier to entry and the need to train various individuals. And so you probably remember on the other screen where I was showing the grid or the web client, I was able to select the grid. In this case, I'm going to enter the same grid for the chaos for the chaos simulator, except I'm going to do it in VR. And so now I don't have browsers. I am trying to use ambient information to relay what's happening. And so I just have an avatar that's sitting in plain space, and she happens to stand on top of a grid or on top of a screen. And so if I can get some volunteers, I would really appreciate it. That link that I sent in the Teams chat earlier, can you or any number of people, especially if you're in front of a computer, I think all of us are, can you just go ahead and open that and click some buttons and do like the SQL query or the break functionality? It doesn't matter. Just click a bunch of buttons. So what you see, thank you. I can already tell people have clicked. This is awesome. Um, as you can see, she's standing on top of this grid that's full of dots, and they look like dots, but it's just one way to represent. What they really are, they're cubes, they're stacks that represent the traces. So if I go into the actual grid of that, oops, then I will see the operations in space, and I can see that this thing ran a SQL select query, right? Um, what I will also see that it is mostly green. So if anybody introduced some chaos and let's do another round of clicks, we'll see that there's a bunch of red. Thank you, whoever clicked that red button. There's a bunch of red. Sorry, I'm geeking out. This is great. I love playing with this. And so now I can tentatively see, wow, this is generally healthy, or there's issues with the system just by looking at the colors, right? So I didn't have to go and do any log surfing. I just had to go and look at some colors. And so now if I look at this screen that used to look like dots, now I know that they're not just dots, they're representative of the health of the system. And I could take a look at them. And just it could just be a fancy screensaver to some degree. I could just plop that on the knock table or some other screen that I have no use for. But effectively, I can just have that ambient information. Now this is the traces. This was the thing where I was showing the flame graph, where each individual part of the flame graph is now represented by a cube. So if I looked at a flame graph and it was 20 things long, then I could just immediately surmise, oh my God, this complexity of this button click was ridiculous. Um, so again, back to the ambient knowledge, ambient information. Now, what I'm looking at here is a camera that's kind of just showing me the stuff that's underneath me, really. And so this stuff is what you were asking about, Joe, which is the servers. And so I have two servers here, and they're interacting with their dependencies. And this is kind of far away, so I'm just going to make my way over there and take a look. And so what I'm seeing, here's one server, and there's another server. And so they're platforms floating in space. A lot of times in observability tools, you'll have that stuff, but it's not dynamic. And so what that does is effectively every time things communicate with each other. So this right here on the left-hand side is the server. These are its dependencies. So it's one of those is a Redis cache, one is a SQL server, one is something else. And effectively, the more they talk to each other, they generate a graph that I can look at and go, "Ooh, there's smoke coming from this. It's really on fire because there was a bunch of errors that showed up." And so I'm going to change my view here. And I'm just going to restart this whole process just so that we could see yet a different angle and show some of that ambient. So all the people that click buttons, thank you. Hold the button clicking for just a second. and I'm just going to log back in. And I'm not sharing, so I will share one more time. Okay, so I'm here and I'm going to enter this grid. Now, we talked about reducing the barrier to entry. Now, this is me clicking mouse buttons and using keyboard to move around, right? However, if I did this, and I think, can you still see me on the camera? Can I get a thumbs up?
Yes.
Okay. So now I'm here. And can you see me moving?
Yes,
You guys see me
indeed.
moving? Hello?
Yes, we see you moving around.
Okay. Can we get some more clicks, please? And I'll show you what I see. So those that are clicking, I should start seeing a platform. So there's a new platform, and you'll see that things are, you probably didn't notice it, but the um, the platform to the right just pulled a bunch of platforms were pulled in from the right. So this server on the left-hand side started talking to a bunch of dependencies. Because of that relationship, those dependencies are now pulled to server. If there was more instances of that server, and there's talking to the same dependencies, then the graph would just grow. You don't really see it at the moment, but it can get pretty busy. And then obviously now I think we're having some errors. That's why it's on fire. And I don't know if you also noticed there's photons that are going back and forth. So as communication gets really heavy, then you see a whole lot of photons flying around. And this demo app doesn't really do this visualization justice. And at some point, let's see. So if I go back, and then I can have a different experience altogether. So now if I went to the grid itself, I can just interact with those boxes. And at some point, I don't know if I can do it now. I don't think I can do it to grab them, but I can hold them. And they should probably shrink, but they don't shrink at the moment. And so let's say that there was an error that was red that I was really interested in, and then I could grab that error and just kind of put it in my backpack. And then I can go anywhere else, or it will be saved to my profile and say, you know what, this is failing right now. This is what I need you to look at. And so this is an experiment on all kinds of usability things, like, this UI that you see up top for ambient information. I could spin up some menus that I can do. I can spin charts that are around me. But I have infinite space. Like, I can represent anything that I'm interested in just by being in this area. And I didn't have to do anything but change or put my headset on for the client to figure out that I already had my headset on to do what it needed. So,
Hey, Dobry, I think we're
1 minute left for
short on
questions.
time.
I'm happy to stay. I think there's an okay if anybody wants to stay as well, but I will open it up to questions to me or to John or to Carl. I don't know, I'm pointing this way, but Carl, you're over there apparently. And so, yeah, floor is open. Feedback, questions, please let us know what you think.
You had a question about accreditation and operation on classified networks, and from Lewis Watkins. And I would start by just indicating or suggesting that you've worked with enterprise software that's made it all the way to TEM.
John wanted to share something. John, do you want me to read that for you, or?
Sure. I just added the notes for people that have chat open.
Well, in the interest of time, John posted a scenario. Please take a look. Are there any questions, feedback, thoughts, opportunities? I'm going to go back to this to the slide just so that I can share the contact slide. But the bottom line is that we are done. So share it one more time for contact information. All of this data, all of this that we showed today is available. There's no proprietary information on here. This deck was shared with the audience earlier. There's specific email addresses we could use for further discussions if anybody is interested in being a champion or a partner or start a relationship with Immersive Fusion. And then those are the specific contacts for this talk. Can I get a thumbs up that everybody sees that still? Because I keep jumping around sharing things. Do you see the
Yes, we
contact
see
slide?
Yes, we see it.
And I would just reiterate, there was one question about getting an ATO on a classified network. And, this is a, initial first kind of partnering search for demonstration and exploration, not for deployment on classified networks at this time. However, the team members here have experience with having software deployed on classified networks, and Dobry's worked with products that are very substantially been vetted and gone through the FedRAMP process all the way to TRL 9. So that's, it's not a foreign concept. This is just an effort to get things seen in labs and potentially a way to do monitoring and analysis that is much easier. If you think of all the work that's necessary to instrument and get things, get the mainline products out there running, the instrumentation and professional services need to run them can be crushing. And this is really designed to make it very easy to push the capability to end users, to people wearing green suits or blue suits, so that they can get their hands on something and do 90% of the work or triage themselves, where they can self-care without having to escalate to a contractor that's extremely expensive because they had to be sourced from CACI or SAIC or Leidos or someone with a clearance, and they sit around and wait for you to pass problems to them. This is a different way to approach things to make it possible for the users themselves to do a lot of self-care and to actually see the problem. And so it's the note I posted in chat is just try and imagine that you're a volunteer firefighter being sent to a foreign country, you don't speak the language, you don't have money, you get to the airport, you can't even get a cab, and so you just kind of hike to a hill and try and look over the city. And Immersive Fusion or Immersive APM makes the problem look like a burning building. And the bigger the problem, the bigger the burning building, the uglier it is. And it's just it's meant to be a more intuitive way to do things. And to showcase this, we've even built a universal tool, kind of a chaos simulator, where you could take any APM platform, whether it was Splunk or Swimlane or Datadog or you name it, and actually see what effort it takes to get those things to a useful point, and then also to be able to see what's been done here, which is to take the open telemetry standard and just say, throw it in the box and it works. And it's just a very easy way to get to the root cause, or to get to the cause of a problem, and either fix it yourself or have the user fix it themselves, or to be able to easily pass it to their resources internally with a description of the problem and the appropriate code to say, here's the problem, please take a look at it. And if I've missed anything, Dobry, please smack me. But I think that's a pretty good, decent description.
No, that was really good, John. Thank you. Thank you. I know we're over time. And Carl, I don't want to put you on the spot, but can you, if you're able to, can you share something about your experience and ease of use?
Yeah, we had used Immersive Fusion in a distributed application. We had a task that was broken up. Oh, sorry. Can you hear?
Yeah, I still can't hear you. Sorry, Carl. But yeah,
I can hear him.
You can? All right, I can. Okay. All right.
All right, I'll continue, assuming that people can hear me. We used the Immersive Fusion product in a distributed system. We had a task that was broken up and spread across multiple cloud instances, and we were able to track a task going across multiple VMs in that distributed environment. When a problem happened in any one of the VMs that were there, we were able to determine which VM was the problem and how it was working in the context of the overall task. So Immersive Fusion really was able to alleviate the time that was spent in tracking down where the problem was and identify quickly and allow us to get to the root cause immediately, as opposed to going through doing the log analysis as he's demonstrated. It's a very intuitive tool to use, and I'm happy to answer any other questions in regard to that.
I couldn't really hear Carl. Are you still saying?
Dobry, can you hear me?
I can hear you, but I can't
Okay.
hear him.
We heard Carl quite well. So whatever audio gymnastics is happening, everyone heard it except for you. And
Okay.
he described a problem. He described a scenario that the testing, the experimental that they had done, and tracking a problem across multiple VMs. And he gave a very nice description. So that was good.
Nice. Okay, cool. Well, thanks, Carl. Thanks everybody for joining today. This was a privilege. I enjoyed giving this talk, and you could probably hear some excitement when we get into the VR. But there's a lot of opportunity. There's a lot of innovation that we have the opportunity to really embrace and solve some problems. Thank you for your support, and we'll chat soon. Back to you, Mr. Coaches.
All right, thank you. I'd like to thank Immersive Fusion for coming in today, giving this excellent presentation to our audience. Really appreciate it. Thanks everyone in the audience for taking time out of your day to take part in this technical exchange meeting. If you're interested in further exploring this capability, the contact information for the company is on the screen right now, so please feel free to reach out to them. Also, if you don't feel comfortable reaching out to the company directly, you could talk to my organization, the DISA Emerging Technology Directorate, and we can intercede in discussions with the company on your behalf. Also, I'd like to put a plug in for our DISA Works Innovation Lab, which is located in Columbia, Maryland, where I'm actually located right now. DISA Works is our lab space to perform testing, piloting, evaluation of technologies that are out in industry, such as this one. We are off Fort Meade, so we don't have all the security restrictions from being on the fort. So if anyone is interested in looking at this technology or any other technologies that are out there in industry within our DISA Works lab space, please reach out to my organization for further discussions. So again, thanks everyone for your time today. Wish you all a wonderful day. Take care, everyone.
Thank you very much. Have a great week.